objective for this section is I can identify, evaluate, graph, and write linear functions, which sounds like a lot to cover, and I probably won't cover it all in one video, but to be fair, you already know how to do most of this. When we're talking about linear functions, and this is part of our vocabulary, a linear function is just a function that makes a straight line, right? It's a function whose graph is a line and a straight line. Okay, that's linear. And we all know that I cannot draw straight lines, but let's just say that that's a straight line. Okay, so any straight line between 2 points, that would be a linear function. Function notation might be where we kind of run into a little bit more difficulty. Function notation, I'll look at the definition, is a method for writing variables as a function of other variables. The variable y becomes a function of x, meaning the variable x is used to find the value of y. Confusing, right? So function notation, which I'm going to do a little arrow, function of notation is we have something like this. F of x equals 2x plus 4. We're used to writing this as y equals 2x plus 4. But when we write it like this, f of x, and this looks like f times x, right? Because of the parentheses, that's something that we're just going to have to get over. That's not true. When we say it like this, f of x, that means f of x and y, these are the same thing, okay? And if you want to go through and change all of the things that you have to evaluate to a y to be able to figure it out, if that makes more sense for you, I don't have any problem with that. But what they're trying to say is we have this function f of x, okay, and it's kind of like a little machine. And the little machine, I probably shouldn't try and draw it like they do. We have this machine, and up here at the top we have our input, which is our independent variable, our x. We can throw in whatever x we want. And then we have this machine. This machine is our f of x. And then we get out our y, or we get out our f of x. So our output. I guess f of x may not be the best thing to put in there, but I'm not, yeah. So this is our output. This is our f of x. It's the same thing. So based off of, so let's just do a couple of real quick examples. So we have this machine, our function, I forgot to put the output. The output's right here. We have this machine. We're going to throw in some x's. X goes in, and our function is 5x plus 1, and so out comes f of x, which would be 5x plus 1. So what happens, so this x right here, every whatever value we throw in, that's what we're going to put in here. So let's say we want to know what happens if we throw a 3 into the machine. So f of 3 equals what? And so we throw a 3 in the machine. And then, so because whatever we throw in the machine, it gets multiplied by 5. So 5 times 3 plus 1, that's 16. So f of 3 would equal 16. I hope that makes sense. I'm not trying to make it any more confusing or give you guys anything like new that I'm just trying to give you another way of picturing this. Whatever x value we're going to use, we want to be able to plug it in here. So that's why we write it this way, is so that we can see what it is we're evaluating. So if f of x equals 5x plus 1, then f of 3 would equal 5 times 3 plus 1. Okay? Hopefully that's not too confusing and it makes sense. The more you do it, kind of the more it makes sense. And then when you see something where it says what is f of 8, then you know that you just say, okay, well, I'm just putting this 8 in the machine. So 5 times 8 is 40 plus 1 is 41. Okay, so that's what we want to get through for this section.